Alright guys, welcome back to another video. In this video we're going to be looking at exponents and how to solve some problems with some exponents that maybe you haven't dealt with before. So first of all, we're going to look at roots. So I'm talking about like square roots and then a little more advanced roots. So when we see this problem right here that says find the indicated real nth root of a, that means we're going to take a root, so we're going to use this little check mark of a, negative 125, but then the base of that root is going to be whatever n is. So we're going to put a 3 right here. So we're saying like a square root would be what times what gives you this thing inside the radical. With a cubed root, we're looking for what times what times what gives you negative 125. And of course, for this one, it's negative 5. Negative 5 times negative 5 times negative 5 gives us negative 125. So the answer to this problem right here is negative 5. This is a traditional square root right here because the base is 2. So it'd be square root of negative 400. This one over here would be the 6th root of 64. And I think that this one is 2. And not just 2, but could also be negative 2. So this is an important rule. Whenever you have an even n, then you're going to get a positive and a negative answer. Think of like when you take the square root of 100. You get positive 10, because 10 times 10 is 100, but also could be negative 10. Negative 10 times negative 10 is 100. So anytime your n is an even number, then you're going to get two answers, positive or negative. So 2 times 2 times 2 times 2 times 2 times 2 gives us 64. And negative 2 times 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 negative 2 gives us 64 as well. All right, let's look at a little more advanced roots down here. Anytime you have a fraction, whatever is in the denominator of that fraction, so let's say we take 64 to the 1/2 root. Anytime you have a fractional root like this, or a fractional exponent, I should say. Anytime you have a fractional exponent, really the denominator of that fraction is telling you to take a root. So we could rewrite this as the square root of 64, where 2 is the base of square root. And when we do a square root, we don't actually write the 2, but we could. If there's nothing necessarily wrong with that. We just don't by convention. So if there's no number here, then it's a base 2. So what is the square root of 64? Well, the square root of 64 is 8, but not just 8. It could also be positive or negative 8, since we have an even n right there. Okay, with this one, we see we have a 3 in the denominator, so that would be a cubed root of negative 127. So it would look something like this, and negative 27. And then the answer to that is what times what times what gives us negative 27, and that would be negative 3. Negative 3. It says to do this without using a calculator, and that's what we're trying to get good at, is kind of understanding these problems without a calculator. But realize that with all of these problems, on a calculator, I could type in the base 32, press the little exponent button on like a TI-83 or a TI-84, and then in parentheses, put in this exponent, 7/5, and it would give me the answer. But let's look at this one. This one has a 5 in the denominator, and then a 7 here. So the way this would work is we would take the 5th root, so whatever's in the denominator goes right here, the 5th root of 32, and whatever that is, we're going to raise that to the 7th power. So whatever is on the numerator of the denominator, or I'm sorry, the numerator of the fraction, we set that up in the top right corner as the exponent. The exponent was just 1, so we didn't have to really do anything because anything to the 1th power is just itself. But this one, since we have a 7 here, then we're going to raise that to the 7th power. So first, let's do the inside here. What times what times what times what times what gives us 32. And of course, the answer is 2, I think. Yeah, 2. So we'll have 2 to the 7th power. And there's only one answer since this is a odd, this is an odd n. So we only have positive 2. And then we raise 2 to the 7th power, which I think is 128. 128. So our overall answer is 128. All right, let's do one more. Change the colors here. This one has a negative in it, so this will be a little more interesting. So I'm trying to think how we want to do this. Let's see. Tell you what, I'll make a separate video. We'll come back to these negative exponents because I want to put that in a separate kind of idea. So we'll move on for now. Okay, we may come back to it here in a minute. All right, so here we're just trying to match the equivalent expression with the exponential view. So we can see this is going to be base 2 and then exponent 3 out here. So that one would be this one right here. Nope, sorry. Not that one, it's this one right here. There we go. 3 is the exponent, and then whatever's in the denominator is the n for our root. Okay, which means that this one goes right here because we have 2 is the exponent, and then 3 is the n. Let's see. This one is just, the exponent is just 1, and then the root, the n, is going to be 3, and the whole thing is negative. But notice what happens when we take a negative of a negative exponent. Really what it does is it puts the whole thing over 1. And this is what I was trying to show you before we went on to that other problem up above. So we're going to go back to that here in a second. But notice when we have a negative exponent, it inverts it to where the whole thing is in the denominator of a fraction. So if we go back up here and try to look at this problem number 7, we can see that this is going to be 49 to the negative 3 halves is going to be 1 over the square root of 49, because 2 is our n. This whole thing is going to be cubed. So we can do this. Okay, so square root of 49, that's 7. So this will be 1 over, and it's plus or minus 7. 1 over plus or minus 7. And then this whole thing is cubed. So 1 over 7 cubed. And let me get a calculator out here, because I don't remember what 7 cubed is. 7 times 7 times 7 gives us 343. So the overall answer is 1 over 343. And of course this is plus or minus. So there you go. So just remember, if you have a negative exponent, it's going to put it all, it's going to invert the number to where it's all under 1. Okay, one last thing, and then we'll wrap up the video, and that's that we can solve equations actually using this. So for this equation number 16, first step would be to divide by 6. So we'll get x cubed equals -1. -6 divided by 6 is -1. And then we take the cubed root, so do the opposite of the exponent. So we'll have x equals the cubed root of -1. So what times what times what gives us -1? And of course the answer is -1. So there's our answer. Let's do one more. For this problem right here, first step would be to divide by 2. So we'll have x plus 5, all this to the 4th power, equals 64. And then if we take the, if we want to get rid of this exponent, we'll take the 4th root of the other side. So we'll have x plus 5 equals the 4th root of 64, which I think, let's see, is that 2? 2 times 2 is 4 times 2 is 8 times 2 is 16. The 4th root of 64. What would that be? Maybe. Well, guys, oh, yeah. No, yeah, we did it right. We divided by 2. 128 divided by 2 is 64. And the 4th root of 64 is, it gives us a fraction. I'm not sure if, I guess this is round your answer to 2 decimal places when appropriate, so I guess we'll do that. It's not going to give us a perfect answer, so we actually have to use a calculator for this one. So we can do 64 to the 1/4 power, and we get, let's see, 2.83. And then we need to subtract the 5 over here. So x equals 2.83 minus 5 will give us negative 2.17. And of course I forgot this is an even root, so we'll have a plus and a minus. So this will be plus or minus 2.83. So the other answer would be negative 2.83 minus 5. So our other answer would be negative 7.83. And there we go. We got 2 answers here. Okay guys, so that's kind of the main idea. But we're going to end the video there. If you have any questions, let me know. But thanks guys for watching, and I'll see you in the next video.